Section 9.6a, Counting Principles, Day 1. In this lesson, students will be able to solve simple counting problems, use the fundamental counting principle to solve counting problems, and use permutations to solve counting problems. Complete the following warm-up problems. Pause the video. The answers will be next after you unpause. Example 1. Suppose you place 8 pieces of paper numbered 1 through 8 in a box. Determine the number of ways you can select one or more numbers. So the first question is, you select a prime number. So our numbers are 1, 2, 3, 4, 5, 6, 7, 8. The ones that are prime are 2, 3, 5, and 7. So the number of ways you can select a prime number is there are 4 ways. You select a number divisible by 3. Once again, our numbers are 1, 2, 3, 4, 5, 6, 7, 8. And the numbers that are divisible by 3 are 3 and 6. So there are 2 ways you can select a number divisible by 3. The last one's a little trickier. It says you select 2 different numbers that add up to 7. So let's look at our numbers. So 1 and 6 are 2 different numbers that would add up to 7. 2 and 5 are 2 different numbers that will add up to 7. 3 and 4 are 2 different numbers that will add up to 7. You also have to look at the numbers that go the other way. So you have to look at if you select 4 and 3, if you select 5 and 2, and if you select 6 and 1. So these 6 possibilities, there are 6 different ways for numbers to add up to 7. What we just did in example 1 is a way to solve counting problems by listing all the possibilities. That's what's called a sample space. However, this is not always the most efficient way to solve the problem. For example, let's look at example 2. You pack in your suitcase for vacation 2 pairs of shoes, 5 shirts, and 3 pairs of shorts. How many different outfits can you make? Well, if we write out all the possibilities, it would take a while. Instead, what we do is we create a slot for each possibilities. So we have a slot for shoes, we have a slot for shirts, and we have a slot for shorts. So you have 2 options for shoes. So we put our 2 in your shoes options. There are 5 options for shirts, and there are 3 options for shorts. What we can do is multiply all those together. 2 times 5 times 3, which means we have 30 possible outfits. What we just did in the last example is an example of the fundamental counting principle, or the slot method. If one event can occur m ways and another event can occur n ways, then the number of ways that both events occurs is m times n. This can be extended to 3 or more events by multiplying the number of ways by each other. We will do several examples that show the fundamental counting principle. Example 3. How many 3-digit numbers can you form where the number is less than 600 and is an even number? So let's think about this. We have a 3-digit number, so we're going to have a slot for each digit. This is the first digit. This is the second digit. This is the third digit. Now we know that the number is less than 600. So since the number is less than 600, we know the first digit must either be a 1, a 2, a 3, a 4, or a 5. There are 5 possible numbers that represent the first digit, so we're going to put a 5 in the first digit. Now we know it's an even number, so in order to be an even number, it means the third digit must be 0, 2, 4, 6, or 8. Once again, there are 5 possibilities, so we need to put a 5 for the third digit. Now the second digit can be anything, so the second digit can be 0, 1, 2, 3, 4, 5, 6, 7, 8, or 9. So there are 10 digits if we include 0, which is a digit. So we put 10 here. So all the numbers that are less, 3-digit numbers that are less than 600 is 5 times 10 times 5, which is 250 numbers. Practice 1. Suppose your computer password must contain 4 characters, which must begin with a capital letter and end with a number. It can only contain digits and letters. How many different passwords are possible? Solve this problem, pause the video, and the next slide will have the answer. Practice 2. How many 5-digit numbers can you form where the number is odd and the second digit must be greater than 5? Solve this problem, pause the video, and the next slide will have the solution. We're now going to complete the permutation exploration. Suppose Julia and Robbie want to take a photo. What are all the possible arrangements for taking the photo? Write the possible arrangements down, and the next slide will have the answers. Now Danielle is joining the picture. Now how many possible arrangements for the photo are there? Record them by giving the sample space, which means writing out all the possibilities. Pause the video and attempt to do this. Here are the possibilities for once Danielle has joined the picture. The last situation is Hannah. Hannah now joins the picture. Now how many possible arrangements for the photo are there? Record them by giving the sample space. There are a lot more, but still not too many to write. Write them below. After looking at all those possibilities, do you see a pattern? Think about the fundamental counting principle and explain it. How many possible photo arrangements would there be if one more person joined the picture? Show your thinking, but don't write out all the possibilities. The answer will be on the next slide. What we just did is an example of a permutation. A permutation is an arrangement of n elements r at a time where order matters. Just like we learned with the binomial theorem, there's C stands for combination, permutations is represented by a P. So NPR, when you have NPR, that means there are n elements and they're arranged r at a time. NPR has a formula. The formula for NPR is NPR equals n factorial divided by n minus r factorial. There's also a button that represents this on a calculator, or you can use slots for permutations. Example 4. At a cross-country meet, there are 30 total runners. How many different ways can the runners come in first, second, and third place? So first of all, we have 30 runners, and they're coming in first, second, and third place. So order matters. When order matters, we know we have a permutation. So I'm going to first do it with slots. So we have 3 slots, a first place slot, a second place slot, a third place slot. So there are 30 possible runners that can come in first place. Now one runner has successfully come in first place. So now we have 29 runners left. And now we have one runner in first, one runner in second. So now we have 28 possible runners for third place. So when we multiply this out, we get 24,360 possible ways the runners can come in first, second, and third place. Now, if we want to use NPR, there are 30 runners, and since order matters, we use P, and we're arranging them in 3 different ways. So 30P3 is also 24,360. Example 5. A club has 15 members. How many ways can there be a president and a vice president? So once again, we have our slots. We have our president slot and we have our vice president slot. 15 people can be president, but now we've picked a president, so there's one fewer people. So now there are 14 options for vice president. So there are 210 ways we could have a president or vice president of this club. Now, if you use the permutation, you would say 15P2 because we have 15 club members and we're arranging them in 2 different ways, president and vice president. 15P2, because it's the same thing, is also 210. Now complete practice 3. There are 9 athletes competing in a gymnastics finals competition. In how many ways can the gold, silver, and bronze medals be awarded? Solve the problem, and on the next slide will be the answer. Practice 4. You're arranging 8 books on a shelf. How many ways can the books be arranged? Pause the video, solve this problem, and check it on the next slide. This is the formula for permutations that was talked about before. You can always use your calculator, but if you want to do it by hand, this is the specific formula. The video is over. Complete the remaining practice problems on the notes and check your answers on Haiku.